Alright, so our second application problem is finding the area of a region between two functions. And as with any question involving area, if you're not supplied with a diagram, it's important that we actually introduce one. Now this question does ask us to sketch the region between the graphs and then find its area. So what we need to do first of all is we just need to find a few key points. So we'll start off with the when x is 0. So when x is 0, e to the x is 1. And when x is 0, y to the x is 0. And then if we just pick another point, we'll pick 2, just because this will give us a little bit of an indication as to which curve sits above the other. So down there. So pick the point, right, when x is equal to 2, y is equal to 2 for y equals x. So we'll put that point there, and then we can draw a straight line function like so. Now, when x equals 2, y, for the function y equals e to the power of x, we end up with y equals e squared, which will be far bigger than 2. Now, we don't need to be, again, this is just a sketch, so I'm just going to draw this above the line, just to illustrate the fact that it does go above the line, and then we'll draw in our exponential function. Again, the accuracy of our sketch isn't going to affect our answer. All it's trying to do with the sketch is determine which function sits above the other one, so then we know how to find this compound area. And we'll say this is the area that we're trying to find in there. So we can write out here that the area is equal to the integral between 0 and 2. For some reason, sorry, there's a 1 written down there, that should be 0. Is the area between 0 and 2 of the top function minus the bottom. And we can write this all in one integral because the limits are consistent throughout. But we're looking at the area between 0 and 2, and therefore we can write this as one integral. So if we go through and evaluate this, so the area is equal to the integral between 0 and 2 of our top function, so e to the power of x minus x dx. If we then go and actually integrate that, e to the x integrates to e to the x, negative x integrates to negative x squared on 2, between 2 and 0. And then if we substitute our values in, we end up with e squared minus 2 squared on 2. Now we sub in 0, e to the 0 minus 0 on 2. And with e squared, 2 squared is 4 on 2 is 2. And then e to the 0 is 1, so minus 1. So we end up with e squared minus 3 units squared. Okay, so just to recap again, look, the sketch doesn't have to be perfect. You're not being marked on the sketch. The sketch is just there because you need to know which function is the top and which function is the bottom. And that's why we had to test those points, just to check that to which function lied above the other one. And then from there, it then becomes a case of just subtracting the bottom away from the top. And again, we can write that as a single integral. In this case here, because we're integrating between the same x limits for both functions.